In this exercise, what I'm doing do is do some exploring baseball stats, and the goal is to find what factors contribute to the most to making the baseball team playoffs. Okay, so this is the data source, and do a read CSV, take a look at the columns, and just take a data frame plot. And what you can see is that there's different features that you have, like the league, the team, the year, uh, the running score, RA, W, um, OPD, SLG, BA, playoffs, ranked season, or ranked playoffs. Um, and so we're our target will be the playoffs. So you just plot the data. There's just various uh, in data. So the graph itself does not reveal, just when you do the plot, does not reveal any important features. Okay, so one of the most important factors that you can have is um, the win percent, and the win percent. So we can get the games played, which would be G, the runs scored, runs allowed, and then from those factors, we can calculate the win percent. So if you think about it, it's kind of logical. If you're hitting the ball out into the field and you're scoring, then if your percentage of runs are high, the runs scored are high, then the odds are that you're going to win. If you're defensive and you block the team from the opponent from making runs, then keep your runs allowed low, then your winning percent goes up. So WP will be our win percent, and then we have wins divided by games played and runs scored by runs allowed. So those would be the two percentages we have: wins percent and wins percent two. So win percent two is a ratio of runs scored by runs allowed. So if you look at that function, um, it just takes and these should be actually, yeah, here it is. Runs scored divided by runs allowed. So we take it and multiply it by, it's kind of a famous equation. Run squared to the second power divided by run squared to the second power plus runs allowed to the second power. And that kind of gives us that important ratio. So we'll look at those two, and we just plot them out as it relates to the 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 winning percent. You notice that there's different um, there's different levels. So it's going to vary. The variance is going to vary from zero point 0.3 to zero point 0.7 and or so, and then looks like for the runs allowed, runs scored, it will be from about zero point 0.3 to zero point 0.7 also. Okay, so then we plot it, and then opponents total base divided by opponents at the base, at the bats. And so that's the OSLG, opponents total bases divided by opponents at the bats. And so and what they're looking there is how many times does the opponent get out into the field and um, they're they're at the bat, or they're on bases. Okay, the next one is OOBP, opponents on base percent. So you can see the kind of a trend of how many times that your opponent's on the base. So that's just showing you if you're a good defensive team or not. Um, then the next thing we want to do is we'll take the runs scored and runs allowed, and we'll calculate a difference. So just take the runs scored minus runs allowed, and that will give us a running difference. And we'll just put that in RD as run difference. So that's the run differential. is the runs allowed minus the runs scored. So if we just look at the run differential, you can see that in the playoffs or the teams that uh, there's somewhere that's in the negative, and then there's some in the positive. So we'll see in a second when we start looking at this data what it means. Okay, so first plot we will do is wins times the runs allowed, and the second one will be wins times runs scored. Third one will be runs scored by runs allowed, and keep the runs scored high to reach the playoffs. So that's the main observation that I discovered in the data. And then we'll look at the wins percent divided by the runs differential. Remember, the runs differential was the equation we had back up here. Let me just go back up here to the runs differential. RD. Let's see, where was that? Yeah. So this is your runs differential, and that's kind of just looking at the runs scored minus the runs allowed. So that would plot it. Okay, so let's look at the first one where we look at runs allowed by the playoffs. So you can see if you're in that higher percentile where you're getting more um, runs allowed, then you're not going to make the playoffs. So keep the runs allowed low, and then runs scored. If you're getting a higher amount of runs scored, then you're going to hit the playoffs. Runs allowed by runs scored. You could kind of see a linear correlation here, that there might be some correlation between runs scored and run allowed. Okay, the run differential by the win percent, and definitely a correlation there. And I think that's why the run differential is used so much in predicting the stats on baseball. And then the last one is the run differential by the win percent. And again, that looks linear. So I would say that the run differential by the win percent too, which would be the runs scored and the runs allowed, that there is a strong correlation there. Okay, so let's start analyzing this. We'll look at the first one, which is the team by the run differential, and then we'll look at the win percent two, looking at the runs scored, runs allowed, and then we'll look at the playoffs divided by the playoff count, total playoff count. So we'll see which ones are getting into the playoffs. So you can see that the win percent is the green or the yellow line, and the reached playoff percent is the green line, and then you have the different teams down here. So the win percent, this probably is, you notice that I put that on its own axis, and that's because it has a different a scaling ratio. So we'll just put it on a different axis, and then when we plot it out, when we look at the let's see, the run differential and the win percent to the playoffs, it kind of verifies what the correlations that we were looking at. Okay, in this one we'll look at win percent two, win percent, playoffs, and run differential. And we'll set those up, and then we'll plot them out. And again, you could kind of see here's the win percent, and what we're looking for here is the team by the win percent. So we'll look at the team by the win percent, and if you can see if the win percent is not high, they're not going to make the playoffs. Okay, and then this one we'll look by teams, by wins, by the year. So just see, are there reoccurring years that they're hitting the high win percent? are they consistently hitting high win percents and they're consistently making the playoffs? So that's what we're trying to look at. So you can't really see the pattern yet. So what I did is I pivoted the data and put it into a heat map. And so here we take the year, the team, the win percent too, and we're gonna we'll this little function here. It's going to transpose the data. We're going to look to see if any of the data has a valid numbers not equal to 0. So that gets rid of all the nulls because nulls kind of skew us out. And then what we'll do is we'll plot the win percent by team and year. Okay, so down the left side was we have the year, and then we have the teams going across the bottom, and then our win percent is showing how they're doing per year. So you can kind of see some of these teams are new, and others have been around a long time, and that they'll have a long vertical bar. And if you have lots of variation in color, then that can tell you that there's big changes in the win percent. So you can see that most of them don't have lots of change in the win percent. So they're just incrementally improving. Okay, now we do the same thing. We'll take the year, the team, the playoffs, and we're going to let's see, the team, the year, the team, the playoffs, and then we'll fill the NAs with 0. And again, we're looking to get rid of all those null values. So the playoffs per year. So these show that what year did these teams make the playoffs. So you can see that every team doesn't make the playoffs every year. So that must mean that there's lots of variation. I mean, this team here, it made the playoffs for a lot of consecutive years, but then there's teams that don't make the playoffs for maybe in the last 10 years, and then all of a sudden they make it, so it's a big deal. Then we could see that we just look at what teams made the playoffs the most. Then this is kind of the rank, and New York is at the top, and then you have Atlanta and Oakland. And so, you could probably pick your favorite team based on, if you divide this line here and then select maybe 1 out of 5, you're going to have a pretty good team based on the odds. Okay, so now what we want to do is take these different factors and put it in a logistic regression model, set up the pipeline, put an lasso penalty on it, and look at the run differential, the wins, the win percent, and the win percent too. And then we'll just put it into a concatenate. What I'm doing here is concatenated the columns to the OHE, one hot encoding, and that's to encode the different teams. So based on the team, it will have a encoded value, and then so that gives me my X and Y, and then I can set up my train test split, fit it, calculate my probability, make my predictions, and then I'm going to put it in a count plot. So then I put my predictions in my count plot, and I'm going to show that. And then I will set up a pivot table, again using year, my target, which should be the playoffs, win percent too, calculate the mean, fill it, and then put it in a heat map, and we'll see how that works. So here are my count plot for the ones that don't make the playoffs and the ones that do. So you can see there's a higher percentage of teams that don't make the playoff. And then when I put it in my count plot, I'm looking at what factors were the most important for determining if they hit the playoffs. Okay, and the last thing to do is take the mean win percent. And so you can see through this, it took a little bit of thought, that it's kind of started off with just lots of noise in the data, but I utilize the heat plot and the pivot tables to tell me what features were important, and then I continued to refine the data until I could understand what factors were most important. And you can see that win percent two was very important. And the reason why is because it has that runs allowed, runs scored, and it has everything that the run differential has, and so it's a very important feature. So if you're very popular, if you like baseball, then the thing to do is to watch those key indicators, because they pretty much summarize and predict how the team will do. Okay, well, happy Python coding. Until next time, talk to you later.